Good evening, my fellow scientists. It is Monday, October 16th, 2017, and I want to talk a little bit about precision medicine. That's an idea I've been thinking about a lot the last few days as I've been crafting an application for funding from the National Institutes of Health. And precision medicine is a buzzword right now, so I didn't pitch my idea as the next thing in precision medicine, but I think it relates. The notion is that if you could measure what people would benefit from a treatment very precisely, then you'd be able to guide treatment that much more effectively. That seems pretty straightforward. I mean, you don't use blood from the wrong donor to donate to someone with a conflicting blood type. That's been established for 100 years. How much more specific can we get? Can we know that a particular person's cancer will respond to this drug and not that drug? Can we know that a particular person's spinal cord injury can be treated with anti-inflammatories effectively while someone else's cannot and shouldn't be? And that was the subject of the grant in question, was to ask, can we sort folks who've been injured and who will just recover away from folks who've been injured who won't recover, who need intervention? Because if we could sort people who weren't going to recover, then physicians could intervene. They could do surgery to reduce pressure. They could introduce anti-inflammatories to bring down the scar-forming pro-inflammatory macrophages infiltration. All kinds of treatments could be explored that right now you just can't do ethically just because you don't know who is going to recover without that treatment. What if that same kind of treatment actually interfered with the recovery of someone who was going to recover? That's unacceptable. So in the end, we choose to do nothing in lots of cases. If we had a precise guidance mechanism to tell us, okay, that person isn't going to recover, let's try an anti-inflammatory. That person is not going to recover, let's relieve pressure. That would potentially make a big difference, not just to the people with whom we intervened, but to the researchers who then have so much more data on what works and what doesn't, what works under what circumstances, what predictive circumstances and what doesn't. So this guidance of medicine with analytical chemistry is where I've been spending my time that I'm not spending on batteries or teaching. It's a busy life. But there's a great article in Science a few months ago that slipped under my radar about the economics of precision medicine. How do you make it so that precision medicine is incentivized by the market? And that's a tough question, because although you might make medicine more effective, potentially you're also making it that much more expensive. You're adding that many more tests to the process, sorting people into that much more costly a treatment, when it might be in the insurance best interest to just pretend like such information isn't available and that no treatment is the most ethical course for everyone. That conflict of interest is going to be really hard to manage going forward. And this paper talks about lots of issues, not just that one. Issues like, tax breaks for doing research in such diagnostics. And that's great, but I do wonder about the hard economic issues of our time and how those are going to affect the kinds of knowledge and resources that we can bring to bear effectively. So I'm afraid I don't have much of a conclusion on that. It's a big question with no answers yet, but it's hot on my mind, so I thought I'd share. If you like that kind of thing, leave me a comment. Let me know what you're thinking on this issue, and if we get that going, we'll continue the conversation next time. Otherwise, it's back to batteries just as soon as I can get back in the lab. In the meantime, I update Monday through Friday. We talk about science and science policy once in a very great while. Mostly talk about batteries and results right here in the Allen Lab.